Hello girls, today we are going to discuss Chapter 2, Lesson 1, Universal Gravitational Force. Newton's Universal Gravitational Law. By noticing the motion of falling objects, Isaac Newton had concluded some basic assumptions that helped him to formulate the general gravitational law. Of these assumptions are 1. Objects fall due to Earth's attraction to the object and object's attraction to Earth. 2. Gravitational attraction between bodies extends over vast distances. Example, between the Sun and planets or between Earth and the Moon. 3. Gravitational attraction between bodies depends on 1. Masses of bodies. 2. Distance between them. Through these assumptions, he formulated the general gravitational law as follows. Universal gravitational law. A body in the universe attracts another body by a force which is directly proportional to the product of their masses and inversely proportional to square the distance between their centers. What does this mean? If we have two bodies, one with mass m capital and the other with mass m small, and the distance between their centers is r, so we can calculate the force between them by this equation. We can say that the force of attraction between them is directly proportional to the product of their masses over square the distance between their centers. So, from this equation, we can deduce the mathematical equation for the general gravitational law, which says that force equals gravitational constant times m capital times m small over r to the power 2. And also from this equation we can deduce the gravitational constant, which will equal force r to the power 2 over m capital times m small. Now we can define the gravitational constant. It is the force between two bodies each of mass 1 kilogram and the distance between their centers is 1 meter. What does this mean? This means that the gravitational constant will be equal the attraction force between the two bodies when the mass of each body is 1 kilogram and square the distance will be 1 meter square. So the gravitational constant will be equal the force of attraction between them. Now this is the rule of the gravitational constant. So it's very important to know its measuring unit, which is Newton meter power 2 per kilogram power 2 or meter power 3 over kilogram second power 2. And it's very important also to know the dimensional formula of the gravitational constant, which is meter power negative 1 L to the power 3 T to the power negative 2. And the last thing is the numerical value of the gravitational constant, which is equal to 6.67 times 10 to the power negative 11 meter power 3 over kilogram second power 2. Here comes a very important question. What's meant by the general gravitational constant equals 6.67 times 10 to the power negative 11? It means that the attraction force between two bodies, each of them is 1 kilogram, and square the distance between them is 1 meter square, equals to 6.67 times 10 to the power negative 11 Newton. Now we are going to discuss the factors affecting gravitational force between two bodies, and we of course get these factors from the equation. 1. The product of the two masses. The relation between the force and the product, the two masses, is a direct relation, as we can see, because it is a straight line passing through the origin. How can we get the slope? When we cross out what is on the graph, cross out the f, cross out m times m, we will find that the slope will be g capital over r to the power 2. The second factor is the square the distance between the centers of the two masses. The relation is between the force and the distance between the two masses. It is an indirect relation, as we can see, so the slope will be equals f r to the power 2 equals g m capital M small. And here is an example to solve depending on our rule. The given is the mass of Jupiter, the mass of the Sun, the distance between their centers, and he gives me the gravitational constant and asks me to find the attraction force. So we are going to write our rule F equals G M capital M small over R to the power 2 and answer the example. It's very, very easy. Thank you, girls, for listening.